Today we're getting into a new unit based on the probability of simple events. So we're going to be working on probability for the next 2 weeks, and you should be at the bottom of your page right now. So let's get started. So let's go ahead and start with just basic vocabulary. So what is a probability of simple events happening? Just things that are standalone. So let's go ahead and see our definitions first. So our objective, first of all, is that you'll be able to find the probability or the chance of something happening, a simple event specifically. And again, the central question is how do you find the probability of a simple event? So here we go. So vocabulary, our first word is going to be the outcome. So the outcome is one possible result of a probability problem. So again, how many times is it going to happen? Sample space is a list of all possible outcomes for a probability event. So with a die, when you roll a die, you have 6 options, a 1, a 2, a 3, a 4, and a 5. So that's the sample space. That's what can possibly happen. Random, again, that's the outcomes that occur at random if each outcome is equally likely to occur. So again, when we're doing these problems, we're assuming everything has an equal chance of happening and it's fair. And a simple event is just a specific outcome or type of outcome. So it's not something that's going to be, if I roll 2 die or if I roll a coin, a die and a coin, and some other thing is happening, it's just straightforward. So go ahead and make sure you pause if you haven't gotten all your definitions down and fill in all those blanks. Otherwise, pause the video. Let's go ahead and move on. So we're going to go into a quick real-world example. So let's say Best Buy is having an iPod giveaway. They put all the iPod shuffles in a bag. Customers may choose an iPad without looking at the color. So inside of the bag, there are 4 orange, 5 blue, 6 green, and 5 pink iPods. So if Maria chooses an iPod at random, what is the probability she will choose an orange iPod? So this is a sample example of a simple event within a world problem. So again, we have to figure out what are her chances of picking that orange iPod? So I'll let you guys think about it for a second. You can go ahead and pause the video. We'll get into it in about a few seconds once you've thought about it. So in this case, we need to see how many total iPods there are in the bag. So we have 4 orange, 5 blue, 6 green, and 5 pink iPods. So there are a total of 20 iPods in the bag. So she has to pick one out of these 20 iPods. And from these iPods, 4 of them are orange. So what we get into is the notation of this. So in this case, we have 4 out of 20 are orange. So that reduces down to 1/5. And if you divide 1 divided by 5, you're going to get 0.20 or 20%. So she's got a 1 in 5 chance of picking that orange iPod because there are 20 iPods in the bag. So looking at just this notation, this is how we're going to write it. We're going to put the letter P for probability. Inside the parentheses, it's kind of like function notation. You put what you want to happen. So in this case, we want an orange iPod. If we wanted a probability of a blue, we would say P of blue, and so on. So this is just kind of an intro. Let's go ahead and get into the nitty-gritty now. So what is probability? Give the video a chance to catch up. Here we go. So probability is a chance that some event will happen. So what's the chances of this happening, or what are the chances of that happening? And when it comes to chances, it's always out of 100%. So it's a ratio. Again, ratio means fraction. So it is a ratio of the number of ways a certain event can occur to the total number of possible outcomes. So the ratio, meaning the fraction, the top of the fraction is how often does what I want going to happen over the total options that there are. So what I want goes on the top, how many there are of what I want. The denominator is the total options that there are available, or the total number of events. So get your notes down for this and switch the pause the video if needed. So let's get into just the definition again. It's the number of desired outcomes. It's what you want at the top. What do I want to happen? So P of event is what I want to happen. That's the desired outcome over the total number of possible outcomes. So what are the complete options that are available, even if it's something I want or something I don't want, versus what I want. So what I want, or the number of the event, goes at the top, total goes at the bottom. Fill in the blanks as needed. So again, here's examples of things that use probability. You have this already on your paper. Rolling dice. spinners, like spinning something and seeing where it lands, tossing a coin, heads or tails, grabbing a deck of cards. What are the chances of getting an ace or a red card or a hearts or a specific number, odd number, even number? And just an alphabet, how often does something happen, etc. There's a lot of other options of things that we can find the probability of. And then we're going to go into the probability in terms of percentages. So go ahead and switch to the next page now. So you guys have this little chart already. What is the probability? Something can be somewhere between 0 and 100%. Again, we just divided it into quarters, 0, 25, 50, 75, 100. So if something has a 0% chance of happening, it's at 0. If it's 25%, it's 1/4 or 0.25. If it's 50%, it's half or 0.5 or 0.50. If it's 75%, 3/4 or 0.75. And if something has a probability of happening 100%, it's 1. So it's just going from decimals to percents or fractions. So on the left side, if something has a 0% probability, it's not going to happen. If something has a 100% probability, it's going to happen. And if it's at 50%, it's like half and half of happening. It might happen, it might not happen half the time. And then we get into like not, that means that it's impossible on the left, certain it's going to happen on the right. In the middle, it's equally likely one versus the other one can happen. It's like tossing a coin. Half the time you'll get heads, half the time you'll get tails. Now, with the 25%, it's something that's not very likely to happen, but it can still happen. And on the 75% side, it's somewhat likely to happen. So it's more likely to happen than not. So go ahead and fill those words in and numbers into your table on your notes. Pause if necessary. Sorry, I forgot the words likely. So one more time, it should be not very likely, somewhat likely. Let the video catch up. It's barely going to come in. There it is. So don't forget the word likely on those two. I'm not sure why it didn't pop up the first time. All right, so let's go into your examples. Mine are going to look a little different, but you guys have all the basics on your paper. So middle section, it says P of event with a big giant bar. You don't need to write that part. That's just as a reminder. So we roll a dice meaning two of them. We roll a set of dice. What is the probability of rolling a 4? So we have P of rolling a 4. So on your paper, you should be putting P, parentheses, rolling a 4 equals. So remember, the top of the fraction tells us the number of outcomes. How often can you roll a 4? And the total number of outcomes. So for us, if we have a die, I should say, and there are 6 possible outcomes, a 1, a 2, a 3, a 4, a 5, or 6. So there's only 1 4 in the options. So that would be my numerator. There's only one time that you're going to get a 4 when you roll a dice. And the denominator is 6 because there's a total of 6 different things that can happen. So my answer, it's a 1 in 6 chance that I will get a 4 if I roll a die. So the probability of rolling a 4 is 1 out of 6. So I'm going to have 1/6 as my answer. And this would be the case for any other number. P of rolling a 3, P of rolling a 2, P of rolling a 1. They all have a 1 in 6 chance of happening because they all just appear one time on the die. So let's go ahead and move on to the next one, which was, again, another rolling a die problem. What is the probability of rolling an even number? So on your paper, you guys should be writing P of, in the parentheses, even number. Remember, the numerator is how many times will an even number show up versus the bottom, which is the total number of things that show up. So when you roll a die, to get an even number, that would be if you roll a 2, a 4, or a 6. You can see them right there on the side in yellow. So you can get a 2, a 4, or a 6. So there's 3 different possibilities of getting an even number out of a total of 6 different things that can pop up on the die when you roll it. So we would have 3 out of 6. Which reduces down to 1/2. So again, you should be writing down the P of even number equals 3 over 6, which reduces to 1/2. So again, the probability of rolling an even number is 3 out of 6, or 50%, or 0.5. But we'll be leaving everything as fractions. All right, let's look at the next one. We're looking at the probability of having the spinner. So you may want to label your picture because yours is not in color. You can just put a G on the green, a Y on the yellow, a B on the blue, and an R on the red. So what is the probability of spinning a green? So again, we have 4 different things that can potentially happen. So that would be our total. There's 4 different options, and they're all equally likely. But how many of these 4 options are going to be green? So if you said 1, yeah, there's only 1 green on this spinner. So if I spin it, only 1 section is green out of 4 different sections. So it's 1 out of 4. Again, I don't know why it's written down twice. Just write it once is enough. So 1 out of 4 is your probability of getting a green. So it's a 25% chance, 1 out of 4. So only 1 is green out of 4 different sections. Let's look at the next one. If you flip a coin has 2 sides, heads or tails. So again, number of outcomes versus the total number of outcomes. So the one we want over how many there are. So in a coin, there are 2 sides, heads or tails. So that's going to be our denominator, the total. And from those 2 sides, how many are heads? How many are tails? Only 1 of them. So it's a 1 in 2 chance. Again, you don't have to write 1/2 twice. Let the video catch up. So it's another 50% chance. Half the time you'll get heads, half the time you'll get tails. So it's a 1 in 2 chance, or 0.5, or 50%. Let's go to the next one. So if you have a deck of cards. So again, in case you don't know, a deck of cards has 52 cards, and 1/4 are hearts, 1/4 are clovers, 1/4 are spades, and 1/4 are diamonds. So they ask us, what is the probability of picking a heart? So again, in a deck of cards, you have the ace through 10, and then you have the king, the queen, the joker. So that's a total of 13 cards, times 4, because we have 4 different suits. So in this case, when I'm writing my probability of getting a heart, there are 13 different cards that have a heart on it. Again, 2, 3, 4, 5, 6, 7, 8, 9, 10. The ace, the joker, the queen, the king. And there's a total of 52 cards in a deck. So again, if you reduce it, it's 1 in 4. And this one you could probably figure out because there's only 4 different suits. And then again, for the next one, it's a 1 in 4, 25%. What about not getting a heart, which would be the rest of the cards, which would be 39, which would reduce down to 3/4 in this case. So every 3 out of every 4 cards are going to be non-hearts. This is 75%. If you reduce it or change it to a percent. And let's go ahead and move on to the next one. I want you guys to try out the other 8 problems on your own. So go ahead and pause your video and come back and check your work. All right, now that you've actually gone over these and figured out the spinner. So again, what are the total options here? All of these should be out of 8. But you should always reduce all your numbers. So again, all of these should be something over 8, and then reduce it. So you should have gotten the following. Let's look at our answers. 4 out of 8, which you should be reducing down to 1/2. It's not going to show on the video though. So put equals 1/2. Probability of getting a 1, there's only one in this, so it's 1 out of 8. The probability of getting an odd numbers are 1, 3, 5, and 7, the ones in black. So it's half of them, 4 out of 8, which reduces down to 1/2. And the probability of getting a prime number, numbers that are only divisible by themselves and 1. So the prime numbers are 2, 3, 5, and 7. So it's 4 of them. And that's going to be 1/2 as well because it's 4 out of 8. Let's look at the next one. So again, here we have 4 different options. We're looking for the probability of getting a red, getting a 2, not red, and an even number. So probability of getting a red, it's 2 out of 4. Because 2 of them are red out of 4, so it's half. What's the probability of getting a 2? There's only 1 2 here, so it's 1/4. Probability of not getting a red, which means getting a yellow, it's 2 out of 4, which reduces down to 1/2. And the probability of getting an even number, the only even numbers we have are the yellow numbers, which are 2 and 4, which is half the numbers. 2 out of 4 reduces down to 1/2. All right, let's go to the last problem. You don't have it on your paper, but you can still go ahead and try to answer it on your own. This is a computer company manufactures 2,500 computers each day, which is an average of 100. And what's the probability of it not being defective? So we have a probability of not being defective. So if 100 are going to be defective out of the 2,500, that's going to be 2,400 out of the total of 2,500. This reduces down to 24 over 25 because the zeros cancel. So that's the general thing. Again, you get better at this by just trying out problems. So you guys have a whole bunch of problems to work on. So let's go ahead and get started. And good luck.